Welcome to my laboratory kitchen. Today, the gloves are off, partly because what I'm making today is milk bread, a style of light, fluffy bread common in Asian marketplaces, and because kneading bread in gloves is less than appealing, I thought I'd bare my hands for this one. Scandalous. Here, what I'm starting with is called tangzong. This combines milk and flour into a roux-like paste. But here's where the first bit of science comes in. Working on similar principles as the roux, but for a different outcome, the process of heating the flour in liquid is to instigate a process called starch gelatinization. Gelatinization of the starch is created through the heating of the starches in the presence of water. In this case, flour is the starch and milk provides the moisture. As the water heats, it begins to break down the durable structure of the starch, breaking apart the connective chains in the starch molecule and providing more bonding sites for the hydrogen atoms in the water. As these sites become more available, the starch swells and collects more water. Since water is binding to parts of the starch, it can't easily be freed. This makes the water act as a plasticizer, the term for a chemical process that makes the end material more pliable and flexible. The flour becomes a gummy paste as more and more of the moisture is added to the starch's mass. In the recipe, this serves two major purposes. One, the retained moisture, once it's reheated in the baking process, creates steam, which puffs up the bread as it bakes. Two, the flour also retains moisture after the baking process, preventing the bread from drying out quickly and increasing the shelf life of the loaf. However, that's far from the only fascinating thing about baking bread. As I'm putting together the dry ingredients, I'm adding one of the key components to this particular type of bread: yeast. Yeast is a microorganism that processes sugars for energy, just like people can, and also like people, the process produces a waste product. In this case, for the purposes of our bread, it's carbon dioxide in order to make the bread rise. The carbon dioxide, as a gas, is already a collection of widely dispersed molecules. Since the amount of energy required to shift carbon dioxide into a liquid or solid state is immense, the gas instead builds into pockets, pressing outward as the pressure increases. These pockets help to create the rise in the bread. That's not the only interesting bit, however. Yeast also produces alcohol. Yep, even baker's yeast. The anaerobic process, the way that yeast can convert sugar to energy without requiring oxygen as a catalyst, can also produce alcohol. While people take advantage of that when making things like beer and wine, the reason it happens is far more ingenious. See, ethanol, the type of alcohol commonly produced, is capable of denaturing proteins and disrupting cell membranes. These two processes are why alcohols can be used as antiseptics. They kill off bacteria and other microorganisms. However, the yeast is resistant to alcohol in the levels it normally produces. That means the yeast is specifically creating an organic chemical to kill off anyone else that would try to steal its food supply. Don't worry, though. The bread doesn't ferment nearly long enough to produce a significant amount of alcohol, and the majority burns off in the oven when the yeast is killed and the bread bakes. Still, you have to admit, it's a far more effective process than smacking someone's hand away from your fries. And remember, as always, cooking isn't magic. It's science.